In this video, we'll be using 3 different methods to estimate the fixed cost and variable costs using the linear cost equation assumption. The first method that we'll be taking a look at is the scatter graph. We have data provided to us from Canyon Veterinary Services that we'll be using to create this scatter graph. The Veterinary Services Company is a specialized vet practice whose only service is administering vaccines. To create a scatter graph, we'll select our data. Under Insert and in the Charts grouping, we'll select the scatter graph option. So we've graphed our data points that are available to us. But if we were to try and draw a line through those points, we can get close to where our fixed costs would intercept our axis, and that would be somewhere between $500 and $1,500. So this gives us an estimate, but isn't very accurate. The next option that we can use is the high-low method. This method is going to use the highest data point, which is February, total cost of $6,000 with 700 vaccines administered, and the lowest point, which is June, where the total cost is $3,200 and the number of vaccines that are administered is 300. We first need to find the differences in our total cost and activity levels. To find the difference in total costs, we'll start with the high cost of $6,000 and subtract the low cost of $3,200. So that gives us a difference in our total cost of $2,800. Next, we need to find the difference in our activity level. The high activity level is 700 vaccines, and we'll subtract the low level of vaccines of 300. So that gives us an activity difference of 400 vaccines. To find the variable cost per unit, we will take the total difference in cost of $2,800 and divide that by the difference in activity of 400 vaccines. So this will give us our variable cost per unit of $7. We can now use this information to help us find our total fixed cost. The total fixed cost is going to equal our total cost for, if we're looking at the month of June, of $3,200 minus the variable cost per unit, which is $7, times the activity level of 300. So this gives us a total fixed cost of $1,100, which does fall in that range that we identified with the scatter graph. If we were to use that same variable cost per unit and plug that into an equation using the high data, we would get that same exact total fixed cost amount of $1,100. So this is a little bit more accurate than the scatter graph, but we are only using 2 data points here. If we want to use a tool that will use all of the available data points, so that could be the limited data that we have here, or it could be tens of thousands of different data points that we have available to us. We can use the data regression tool, and this will give us the most accurate information, fixed cost and a variable cost. First of all, I want to show you how to install this tool if you do not have this available already. We can first check to see if it is available to you. If you click on Data, and in the Analysis grouping, if you have Data Analysis there, you have the tool installed already. If you do not have that there, go to your File menu and select Options and Add-ins. And at the bottom of that page, you want to manage your Excel add-ins. Select OK. Here you'll see that option that the Analysis Toolpak is available. So you want to make sure that that is selected with a check mark and then click OK. And that will install that Toolpak for you. Okay, so to use that analysis tool, we'll select Data Analysis And from our large menu, we want to select regression. So you're doing regression analysis. And click OK. From here, we want to select our Y value. So this is the total cost. And we want to select our X value, which is the number of cavities that were filled. So you can see here I did select my column headings, so that means that I do need to check that label box to show that I am including those headings or those labels. We next have the option to select where the output goes. The default will be to place it on a new worksheet. However, I want to see it on the same page as our data. So I'm going to select my output range as cell E6, and that will just start the output chart in that corner. When I click OK, we will get our summary output chart. There is a lot of information here. The things that we will be concerned with are our coefficients and the R-squared value. So the coefficients that are shown are intercept, that represents our fixed costs of $947.06, and also our variable cost per unit of $7.37. The R-squared value will range in between 0 and 1, and 1 means that there's a perfect fit between the data and the regression line that would be created with using these coefficients in our total cost formula. So the R-squared value we have here of 0.973 is quite accurate. We can also use this regression tool if we have multiple X values, which I'm going to show you on that next worksheet. So using the data regression tool with multiple X values will allow us to split those variable costs in between the number of patients and the number of vaccines that are administered. So which costs are associated with serving a patient and which are associated with each vaccine. So again, we will click Data Analysis to use this tool and select Regression. And here we will select the Y range first. And then in our X input range, we want to select both X values. And again, I did include my column headers, so I do have my labels box checked. And then I still have E6 selected for my output range, so that'll work here. And when we click OK, we'll see that we get a similar report, but we have more coefficients, since in this case we did include another X value for variable costs. So to interpret this output summary, the intercept, which is our fixed cost, is $921.61. The variable costs that would be associated per patient would be $1.23. And then the variable cost that is associated with the number of vaccines that are administered would be $6.55. So we could use that to create a total cost equation that would include both of those variable costs. The R-squared value does show us that the line that would be created with creating that equation would fit our data quite well, since 1 means that there is a perfect fit.